Let's take a look at this grade 10 November paper. Question 1.1. If the distance between two consecutive compressions in a wave is decreased, which one of the following will increase when the wave speed is kept constant? So to answer this question, we can say that V is equal to F times lambda. If the distance between two consecutive compressions is decreased, it means that they are decreasing the wavelength. And if the wave speed is kept constant, that means that frequency and lambda are inversely proportional. So if lambda decreases, frequency will increase. The answer here is C. Question 1.2. The position time graph for a car traveling along a straight horizontal surface is shown below. Now, this position time graph shows us that the velocity of this car is increasing as time passes. Line PQ is a tangent to the curve at time t1. Which one of the following is equal to the gradient of PQ? Now, the gradient of a position time graph gives us the velocity, but because this is a changing velocity over time, because of that curve, the gradient gives us the instantaneous velocity. And instantaneous velocity is simply the velocity at that one specific time or at that instant. So the answer is B. Question 1.3. The kinetic energy of a trolley is E. What will the kinetic energy of the trolley be if its velocity is tripled? So the formula to calculate kinetic energy, EK, is equal to half mv squared. So if I triple the velocity, my new EK is going to be half m into 3v all squared. We can simplify that further. You get half m, 3v all squared is 9v squared. We can now move the 9 over to the front. You get 9 half mv squared, which is 9ek. So the answer is D. Question 1.4. The table below shows the changes in the velocity of a car in intervals of 4 seconds. So when time is 0, velocity is 0. When time is 4, velocity is 7. And from the looks of this, it seems like as the time is increasing, the velocity is increasing. But except at this moment here, between 16 and 28 seconds, the velocity is constant here. Well, actually here, all the way through here. Okay, that's interesting. Which one of the following is correct for the acceleration of the car? The acceleration of the car increases initially for 16 seconds, then remains constant. Okay. B says is initially constant for 16, then becomes 0. Is initially constant for 16 and decreases. D is initially, it increases initially for 16 seconds, then becomes 0. So it's important to remember that in grade 10, there is no such thing as increasing acceleration, right? That's beyond the scope of grade 10. The acceleration doesn't change. So the options that say that acceleration is increasing should be eliminated. So A is out and D is out. Also, you could think of it like, what is acceleration? Acceleration is the change in velocity. So if the velocity is changing, then the acceleration is going to be constant. So we left with B and C. Now, after 16 seconds, we can see that there is no change in the velocity. So if there's no change in the velocity, that means that the acceleration is going to be 0. So the answer here is going to be B. Now I like to think about it visually. So I'm more of a visual type of person. I would like to see this. So we could just sketch this out and it'll make it a bit more easier to understand. From 0 to 16 seconds, the velocity of this object or car, whatever the case is, increases from 0 to 28. So from there to there, it increases here. And then from 16 to 28 seconds, it's constant. 32 seconds. It's constant. So this is actually a velocity time graph. Now, if you remember, the gradient of a velocity time graph gives us the acceleration. So here, if we calculated the gradient there, the gradient is constant. It is a straight line. So gradient is constant. That means the acceleration is constant. And then this part here, there is no gradient. The gradient is 0. That means the acceleration is 0. Now let's take a look at question 1.5. Four identical resistors are connected as shown in the diagram below. Which one of the following relationships is correct for the readings on the voltmeters? So I can see that R1, R2, and R3, that's some sort of parallel combination. I can see R4 is connected in series. Now, R1 and R2 are in parallel with, let's use this color. They are in parallel with R3. So V1 and V2, if I add them up, I'm going to get V3. So V1 plus V2 is equal to V3. Then if I add V4, I'm going to get the total voltage. Because remember, the total voltage that's here needs to be divided among the parallel combination, and it needs to be divided among the series. So let's look at which option matches that. So we can set up two equations here. We can say that total voltage is going to equal the parallel. Now we don't count the parallel twice. It's either we take in the pink branch or the blue branch. So it doesn't matter. So it's either going to be V1 plus V2, then plus V4. Or we could say V total is equal to V1 plus V2 is V3 plus V4. So either one, let's take a look. The option there is going to be C. Question number 2 says a section of a wave is represented below. The frequency of the wave is 2.5 Hertz. Is the above wave a transverse or longitudinal wave? The answer here is that it is a transverse wave. Question 2.1.2, calculate the speed of the wave. So 2.1.2, V is equal to F times lambda. They give us the frequency. The frequency is 2.5. And the wavelength is the distance between two consecutive points in phase. So they've given us the distance between two crests, which is sufficient. So times 0.3, that gives us 0.75 meters per second. Question 2.1.3 says, determine the time x between point A and point B on the graph. Now, point A and point B are separated by, that's one wave, and that's half, a quarter, that's 1.5, and that's 1 3/4. So, one way to solve this would be to say that V, or let's calculate the period first. We can say that the period is equal to 1 over F, 1 over 2.5, which is equal to 0.4 seconds. Now, as we said, there's 1 3/4 waves, so we're simply going to say 0.4 times 1.75, and that's equal to 0.7 seconds. And the reason why this works is because, remember, the period is the time taken for one wave. So 0.4 seconds for one wave, that means 0.4 times 1.75 for 1.75 waves. Question 2.2. Ships use sonar to map and measure the depth of the ocean at different points. This is achieved by emitting sound waves into the sea and detecting the reflected sound. The sound waves emitted by the sonar on a ship takes 0.8 seconds to reach point P, which is on the seabed 1,200 meters below the ship. Q is a second point on the seabed as shown in the diagram below. So 2.2.1 says calculate the speed of sound in seawater at point P. So here all we need to do is we can say that speed is equal to distance divided by time. So from the ship to point P is 1,200 meters, and they tell us that it takes 0.8 seconds to reach that point. So divided by 0.8, and that's equal to 1,500 meters per second. They then tell us it is estimated that the speed of sound in seawater increases by 4.5 meters per second for every 1 degree Celsius increase in temperature. The temperature of the seawater at point Q is 2 degrees higher than that at point P. When a sound wave is emitted directly above point Q, the reflected sound wave is detected 2.5 seconds later. Determine the depth of the sea at point Q. So what we should calculate first is what is the new speed going to be. So the speed is going to be 1,500 plus 2 into 4.5, because they tell us that it increases by 4.5 for every 1 degree, but point Q is 2 degrees higher. So it's going to be 2 times 4.5. So the new speed is going to be 1,509 meters per second. Now we can use the formula speed is equal to distance over time. We know the speed is 1,509. We don't know the distance, but we know the time. So the time to go down and to come up is 2.5 seconds. That means the time to go down must be 1.25 and the time to come back up must be 1.25. So the time to go down is 1.25. That means the distance is going to be 1.25 times 1,509, which is 1,886.25 meters. Let's take a look at question 3. A photon of wavelength 2 times 10 to the power minus 7 meters is located within the X-ray range of the EM spectrum. Question 3.1, write down the speed of this photon in a vacuum. So the speed of any EM wave is going to be 3 times 10 to the power 8 meters per second. Question 3.2, calculate the frequency of the photon. So here we can use the formula C is equal to F times lambda. Now we are using C because it is a constant. So 3 times 10 to the power 8 is equal to the frequency multiplied by the wavelength. They tell us the wavelength is 2 times 10 to the minus 7. The frequency is then equal to, now we divide by 2 times 10 to the minus 7. That's going to give us 1.5 times 10 to the power 15 hertz. Question 3.3.2, not 5.3.2. Calculate the energy of the photon. Now the energy of the photon can be calculated using E is equal to HF. You could use E is equal to HC over lambda. Both will give you the same answer. H is Planck's constant. It is 6,63 times 10 to the power negative 34 multiplied by the frequency, which we've just calculated as 1.5 times 10 to the power 15. And that's going to give us an answer of 9,945 times 10 to the power minus 19 joules. Question 3.3. The wavelength of the photon is doubled. Will the penetrating ability of this photon increase, decrease, or remain the same? Explain the answer. So if we use the formula C is equal to F times lambda, we can see that if the wavelength decreases, let's use increase to match the question. If the wavelength increases, the frequency must decrease because C is a constant. So we know that wavelength and frequency are inversely proportional. So the frequency is going to decrease. But from 3.3.2, we know that E is equal to HF. H is a constant. So if F is decreasing, E is decreasing. And if E is decreasing, the penetrating ability is also going to decrease. Let's take a look at question number 4. Two small identical spheres x and y carrying charges of minus 6 times 10 to the negative 9 and 8 times 10 to the negative 9 coulombs respectively are suspended from a ceiling by means of light strings. Question 4.2, calculate the difference between the number of protons and electrons in sphere X. Now this question is phrased in such a way to try to trick you. All it's asking is to calculate the number of electrons that sphere X either gained or lost. That's all it's asking. It's worth 3 marks. It can't be multiple calculations. So question 4.2, we're going to say that Q is equal to N times QE. Now, it's your choice if you want to substitute a positive value or negative value. I'm going to substitute the negative value just to keep it simple. So X has a charge of minus 6 times 10 to the negative 9, and that's equal to N multiplied by QE is minus 1.6 times 10 to the negative 19. Now you solve for N. N is equal to 3,75 times 10 to the power 10 electrons. Now, it is important to then state whether these were electrons that were gained or lost. Because X has a negative charge, it's going to have gained these electrons. So N is 3.75 times 10 to the 10 electrons gained. Question 4.3. The spheres are brought into contact and are then separated. Question 4.4, we leave out 4.3. 4.4 says calculate the new charge on sphere Y. This is simple. You just got to say that Q new is equal to Q1 plus Q2 divided by 2. That's going to be minus 6 plus 8 divided by 2, which is equal to 8 minus 6 is 2. 2 divided by 2 is 1. So 1 times 10 to the negative 9 coulombs. Now it is important to note that I didn't write the times 10 to the power minus 9 here. Now, the reason why I could omit it is because they are the same. If X and Y had different charges, like for example times 10 to the minus 6 and the other one was times 10 to the minus 9, I can't drop them. I must substitute it in because I'm going to get a different value. Let's take a look at question 5, the electricity question. A battery consisting of 3 identical cells of unknown EMF is connected to 4 resistors as shown in the circuit diagram below. The voltmeter reads 12 volts while ammeter A2 reads 2 amperes. Question 5.2.1 says calculate the effective resistance of the parallel combination. Now the parallel combination is going to be this and it's going to be this. Now because it's simple, there's 2 resistors there, I'm going to use R parallel. So R parallel is going to equal product divided by sum. So product is going to be 6 times 12 divided by 6 plus 12, and that's going to give me an answer of 4. So 4 ohms. Question 5.2.2. Calculate the reading on ammeter A1. Now A1 is reading the total current in the circuit. It's not reading any splits or anything like that. So there's a few ways you could do it. Now I'm going to go with the simplest way that I think we can use to solve this, and that's to use ratios. So if I look at these two branches, 6 is half of 12. And so because the resistors are in a ratio of 2 to 1, the current is also going to be in a ratio of 2 to 1. So the current that's going to be going through this pink branch is going to be half the current that's going through the blue branch, because current takes the path of least resistance. So this is going to be 1 ampere. Now, to calculate the total current, you simply have to add these two branches. So A1 is going to be 2 plus 1, which is 3 amperes. Now, there is a different way to do it, of course, and that involves using formulas or formulae. And what we can do is we can say that since the blue branch and the pink branch are in parallel, the voltage will be the same. So if the voltage is the same, I can calculate the current in the bottom branch, the pink branch. I can say that I is equal to V over R. The voltage in the blue branch and the pink branch will be the same. So 12 divided by the resistance in the pink branch is 12, and that's equal to 1. So here, didn't necessarily have to use ratios. You can do it through calculations. And then you can simply say that A1 is going to equal 2 plus 1, which is 3 amperes. Question 5.2.3 says, calculate the energy transferred to resistor R3 in 2 minutes. So R3 is that. Now energy is the W formula. So if I think about what quantities I know about R3, let's go with 5.2.3. I know the time. It's going to be 2 times 60. It must be in seconds. I know the resistance, and that's 2 ohms. I know the current going through it, which is 3 amperes. So I can use the formula W is equal to I squared RT. So 3 squared times 2 times 120. And that's equal to 2160 joules. Question 5.2.4 says, calculate the EMF of each cell. Now, if we look at this, there are 1, 2, 3 cells there. There are 3 identical cells. Now, to figure out the EMF of the battery before we divide, we have to first figure out what the voltage is going to be between all the other components. So what we can do is we can say the total resistance is going to equal, well, we calculated this as, what was the parallel combination? I think parallel combination was 4. So R total is equal to R parallel plus R series. So in parallel, it was 4 plus series is 2 and 2. So that's 4. So my total resistance is 8 ohms. Now I can calculate the total voltage. So V is equal to I times R. The total current was 3. The total resistance is 8, and that gives us 24 volts. Now I have 24 volts that needs to be divided among those 3 batteries. So each battery is going to be 24 divided by 8, which is equal to 24 divided by 3, which is equal to 8 volts each. Let's take a look at question 5.3. A fifth resistor, R5, is now connected in parallel to R4. Will the EMF of the battery increase, decrease, or remain the same? So 5.3.1, the EMF of the battery is going to remain the same. It's not going to change, right? And 5.3.2, will, because that's the battery. The EMF of the battery is the EMF of the battery. It's not going to change. 5.3.2, will the reading on A1 increase, decrease, or remain the same? And explain your answer. Now, A1 is reading the total current. So, if I add a resistor in parallel, they tell us that it's being added in parallel, the total resistance will decrease. Now, since the total voltage or the EMF is the same, the resistance is going to be inversely proportional to current. So since resistance is decreasing, current will increase. So question 6 now says a forklift starting from point X, so this is the starting point, needs to pick up a package from point Y, which is due east from point X. Okay, the package is thereafter transported to a table which lies 350 meters due west of point X. So this is where it's ending. The entire trip takes the driver 2 minutes to complete. Question 6.2 says calculate the average velocity of the forklift for the entire motion. So velocity is equal to displacement divided by time. So we know the time is going to be 2 times 60 because 2 minutes converted to seconds is 2 times 60. But the displacement is what we need to be careful of. Displacement is the straight line distance from start to finish. So if the forklift driver started at X and ended here, we're just interested in the distance between those 2 points, and that's 350. So 350 divided by 2 times 60 gives us 2.92 meters per second. Now we need to give a direction because velocity is a vector. So where is point Y, not point Y, where is the table relative to the starting point? Well, it's west. So the answer is 2.92 meters per second west. Question 6.3. The average speed of the forklift is 3.75 meters per second. Determine the position of Y relative to point X. So simply they are asking us, what is the distance between point X and point Y? Now, to calculate this, we need to look at the information we've been given. They tell us that the average speed, now speed is equal to distance divided by time. Now let's think about the total distance that this forklift driver traveled. So if the forklift driver started there, he went to point Y, let's call it P meters. We're not sure what it is. So at point Y, then the forklift driver needs to travel back to point X, which is another P meters, and then travel 350 meters to the table. So the total distance that the driver traveled is going to be P plus 350. So speed, well, they've given us the speed. The speed is 3.75. That's equal to, the total distance is going to be P plus P, which is 2P plus 350 divided by the total time that it took the driver is still going to be 2 minutes. So 2 times 60. And now we have an equation where we can solve for P. So P, when you solve for it, is going to equal 50 meters. So we need to answer the question. Determine the position of Y relative to X. So if you are at Y, right? If you are here, where is X? Actually, it's the other way around. If you are at X relative, so the question is saying point Y relative to point X. So if you are at X, where is Y? Y is 50 meters east of you. So the answer now is going to be 50 meters east. So again, determine the position of Y relative to X. So when they say relative to X, it means put yourself at X and then where is Y relative to that point? Let's take a look at question 7. A car and a van are both traveling at a constant velocity of 25 meters per second east on different lanes on the same road.
The driver of the car follows the van, keeping a distance of 5 meters between them. Seeing a box on the lane, the driver of the van brakes and slows down uniformly to stop in 5 seconds. Question 7.1.1, calculate the acceleration of the van while slowing down. So what information do I know about the van? I know its VI is going to be 25 meters per second. I know that the van is stopping in 5 seconds, and I know its VF is going to be 0. So if I want the acceleration, I can use the first equation of motion, which says that VF is equal to VI plus A delta T. 0 is going to equal 25 plus A times 5. That means A is equal to minus 5 meters per second squared. But remember, I can't leave the answer as negative. I need to change it to positive. Now, what direction have I chosen here as positive? Well, I've chosen east as positive since the velocity is positive here. So A is equal to minus 5 meters per second east. So if I need to change it to positive 5 meters per second, it's going to be 5 meters per second squared. So since I've changed the sign, I need to change the direction. Question 7.1.2, if the car continued at its original motion, how far ahead of the van will the car be when the van stops? So in other words, they want to know, in the 5 seconds, where is the car going to be? So let's work that out. So we can simply say that for the car, let's go with the car first. We'll say that the distance traveled by the car is going to equal V times delta T. Now we can use this equation because the car is traveling at a constant velocity, right? So the velocity is 25 times 5 is traveling for 5 seconds, and that's going to equal 125 meters. Now this is the distance traveled by the car in those 5 seconds. Now we do need to calculate how far the van traveled in those 5 seconds as well. So we can use the formula delta x is equal to, now we can't use the v times delta t formula because the van is not traveling at a constant velocity, it's slowing down. So we're going to use the formula vf plus vi over 2 times delta t. So we'll say 0 plus 25 divided by 2 times 5. And that's going to give us an answer of 62.5 meters. So that's the distance traveled by the van. So let's draw a diagram to help us understand what's happening here. So we've got this straight line, we've got the van here, we've got the car there. And this is before anything happens. They are 5 meters apart. So the van in stopping travels 62.5 meters in those 5 seconds. So the van is now here. But the car travels, let's extend it slightly. The car travels 125 meters. So the car travels, and the car is now at this point. So let's call that car. And the question is asking to calculate how far away the two are at this moment. So easy to calculate. We're going to say that the distance is going to equal 125 minus 62.5 minus the 5 that the car had to make up, and that's going to equal 57.5 meters. Question 7.2, after passing the box, the van takes off from rest and accelerates uniformly at 4 meters per second squared for 8 seconds. It thereafter travels at a constant velocity of x meters per second for a further 4 seconds as shown in the graph below. use the graph to determine the value of x. So what we can do is, since we've been given the acceleration here, right, we can use the gradient. We can say that the gradient of a velocity time graph is going to be acceleration. So to calculate gradient here, remember gradient, just like in math, is the change in y over the change in x. So I'm going to say that x minus 0 divided by 8 minus 0 is going to equal the acceleration that they've given us is 4. So x divided by 8 is equal to 4. That means x is equal to 32 meters per second. Question 7.2.2, sketch the acceleration versus time graph for the 12 seconds represented in the graph above. Indicate the relevant time and acceleration values on the graph. Now, as I said earlier on, since this is a straight line, the acceleration is going to be constant. So acceleration time is going to be constant for those 12 seconds, or those 8 seconds. So it's going to be 4 meters per second squared for those 8 seconds. And then in this section, there is no gradient. The gradient is 0. So that means the acceleration is going to be 0 for those seconds between 8 to 12. And that's the acceleration time graph. Acceleration time graphs in grade 10, 11, and 12 is simply horizontal lines. Let's take a look at question 8, the last question in the paper. A 4 kilogram steel ball is pushed from rest from top of a frictionless ramp of unknown height. It passes point B, which is 1 meter above the ground, at a velocity of 5,422 meters per second. The ball eventually reaches the ground at point C. Calculate the mechanical energy of the ball. Now, mechanical energy is equal to, so 8.1, EK plus EP. Now we have so many different positions here, and what we need is we need to pick a position, either A, B, or C, where we know the velocity and the height. Because if we know the height, we can calculate the EP. If we know the velocity, we can calculate the EK. So they tell us the height at point B, and they tell us the velocity at point B. So we're going to use point B. So the EM at point B is going to be the EK at point B, and that's going to be the EP at point B. Now the reason why it doesn't matter is because we know that mechanical energy is going to be the same everywhere. So if we calculate the mechanical energy at B, it's going to be the mechanical energy at A and at C. So EK is equal to half mv squared. The mass is 4. The velocity at B is 5,422, and square that. Potential energy is mgh. The mass is 4. Gravity is 9,8. And the height at B is 1 meter. And when we solve this, we're going to get an answer of 98 joules. Question 8.2. The magnitude of the velocity doubles as the ball rolls from point A to point C. Okay, so whatever the velocity was at A, it's going to be half the velocity at point C. Or simple, the velocity at C is going to be double the velocity at A. The question 8.3 is saying calculate the height of the ramp, and that's worth 5 marks. So let's go ahead and solve that. So first, let's start with point C. So at point C, I can calculate mechanical energy. So mechanical energy at point C is going to be the same as the mechanical energy from point B. So that's going to be 98 joules. So 98 is going to equal half the mass is 8, and the velocity is going to be v squared, right? We don't know what the velocity is, but we know it's v squared, plus the EP here. The EP is mgh, but point C is on the ground, so the height is 0, so that's going to be 0. So I can now solve for v. So v is going to equal 7 meters per second. So the velocity here is 7 meters per second. And since we know the velocity at c, we then know the velocity at a, because they tell us that it doubles as it goes down. So the velocity here is going to be 3,5 meters per second. Now that we know that, we can calculate the height at A. So point A, we can say mechanical energy 98 is equal to half mv squared, so 3.5 squared, plus mgh, so 8 times 9,8 times the height. And now we can solve for the height. The height is equal to 1,875 meters. And that's the whole paper. If you stuck around, thanks so much for watching. Don't forget to leave a like, share, and subscribe for more. And I'll see you in the next one. Bye-bye.